Video 7.4, we are working on analyzing parabolas. So in the previous video, we did a parabola that was opening up, and now we're going to do one that's opening down. So concavity, which way does it open? It opens, oopsies, paranoid. I always like my arrows on there. Down. Don't have to put opens down or anything. Down is good enough. All right, where's the vertex? So I go on my graph and I start going up, and then I look for the point where the direction changes. It's either the bottom or the top of the curve. So in this case, the coordinates are, looks like 1 over and 16 up. Now, is there a maximum or a minimum? Well, as I read my graph going this way, again, it's going up, 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 and then it starts to go down. So that's going to be a maximum. The value. So remember, max and min, you're always looking at vertical. So your equation is going to be y is equal to, and how high does it go? It goes all the way up to 16. Axis of symmetry, right? That is a line that divides your parabola in half, like that. So you got 2 equal halves. It also should always be going through your vertex. If your axis of symmetry does not go through your vertex, something's weird, something's wrong. All right, and the equation of the axis of symmetry is a vertical line, so it starts out with x equals. It crosses the x-axis at where? Well, it's hard to see there, but it crosses at 1. Before we go further, I'm going to do my quick check. So I look at my vertex, and my minimum or max value should be the same. And then I look here, see, it's all matchy-matchy. That is a beautiful thing. So I know that those points are probably right. Now my x-intercepts, it looks like I've got 2. There's one there, and there's one there. So that would be -3 and 0. And if I go to this side, it's going to be 5 and 0. And just to show you, our axis of symmetry, if you count, it's 1, 2, 3, 4 out to there, and 1, 2, 3, 4 out to there. Nice symmetry. Apparently my dog's not too excited about symmetry. All right, we got a y-intercept. There's always going to be one y-intercept. The x-intercepts, you can have 0, you can have 1, you can have 2. We keep showing you ones where they've got 2. But y-intercept, there always, always, always has to be 1. And there it is. And it is 0 and 15. So quick check. 0's at the end. X-intercept y is 0. Y-intercept x is 0. So we're good. The domain. Memorize it, guys. Just memorize it because it's exactly the same every single time. I had a student complain to me, why are you putting on that on a test if it's the same all the time? And someone piped up, so we can get it right. Right? You know what the answer is. Sorry. Okay, range. Now, as I was showing you in the last video, and then comma, that part of the range is the same every single time. So you should be able to memorize that. Don't have to think about it. The other thing is if you look at it this way, our parabola is going to go our y values. See, when we're at 1, there's a graph. At 2, there's a graph. If we go to 10, right, we're hitting the graph. And we're going to keep going until we get to 16. And then anything higher than 16, the graph isn't there anymore. Sorry, the graph isn't there anymore. So y is less than or equal to 16. And this are also going to match because this number is always going to be your maximum minimum or off your vertex. So that's 1, 2, 3 spots where that shows up. Cool. So what I want you to do now while I fix my pen is turn off or pause the video and do this one down here. We're going to spend a lot of this chapter analyzing parabolas, so you need to get used to it and get comfortable with the words. All right, let's do it. Concavity, up, vertex, 1 and 1. Is there a maximum or minimum? Well, anytime it's a smiley face, it's a minimum, right? Because the values keep going down, 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 down until you get to 1, and then they start going up. So that's a minimum. And this is going to be y is equal to 1. And we need to draw on the axis of symmetry. It's going to go down the middle. And that's going to be x equals 1. Okay, it was super easy because there are 1s on this one. X-intercept. Oh. There's my y-axis. There's my x-axis. Right, don't put 0 because that's going to look weird. Put none, or there aren't any, or something like that. But it's okay, because depending on the equation, this parabola can actually shift up and down. So in this case, it has no x-intercepts. If we moved everything down by 1 box, right, if we have this one, drawing's not great. If you had that one, that would have 1 x-intercept. If it came down a little bit further, we have 2 x-intercepts. But that all depends on the equation. So the x-axis can have 0, 1, or 2. Y-intercept, there's always 1. Always, always, always. And you can see it right there. That's going to be 0 and 2. The domain, same as always. X such that x is an element of real numbers. And the range, oops, D equals, make it nice. Range equals the set of all y such that y, now I'm being lazy. I'm reading out the part I have memorized. Now I have to do a little thinking. I know the number that goes in there is going to be 1. And y is, all my values, are they greater than 1 or less than 1? They are greater than 1. So you guys know from the previous chapter, I'm not fond of the less than, greater than. So I do 2 things. 1, don't judge me. This is a smile. And I always think it's always great to smile. And it helps me remember to use a greater than sign. Or, a little more mathy, I know it's going to be a 1 down there, right? Because I know that comes from there all the time. If I just look at any other point on my parabola, this has got coordinates -1 and 5. If I just look here at the y coordinate of it, that'll fit in there. So 5 is greater than or equal to 1. So that must be the way it goes. Truth is, I just remember the smile face is pretty great, so better use the greater than sign. Okay, end of video.